Hello, everybody, and welcome to another Mystery Box Function Challenge. In the purple box, there is some mystery math, and your challenge is to figure out what it is. Because today is Friday, that math is going to be particularly challenging. You can try this out, use the link in the description, and when you think you've got an idea, come on back and see if we get the same thing. Okay, let's begin with a 0. So 0 gives us infinity. We've seen this several times before, and usually what that means is we've got some kind of rational function. So maybe it's x on the bottom, maybe it's x squared on the bottom to give us that error of infinity. Who knows? Maybe it's x cubed, x to the fourth. I don't know, but it's some rational function would be my guess. Let's try some other numbers. Okay, so that's giving us 2. So it's certainly not just 1 over x. Maybe it's 2 over x. Let's try 2. And that's giving us 2.25. So it's certainly not 2 over x. Interesting. Let's go out a little further. Let's try 4. Let's try 8. Ooh, okay. So it looks to me like this curve is getting closer and closer to this diagonal line. So maybe we have a slant asymptote. But let's look at what happens in the fractional areas between 0 and 1. So I'm going to put in 1/2. 4.5, interesting. How about 1/3? Okay, so that's 8.3 repeat. So 8 1/3. Okay. Well, you can see this shape. We had one like this, I think, up last week that looked fairly similar to this. Let's see what's happening in the negatives. Are we going to get another similar arm down here or not? So let's put in a -1. Oh, so that's right on the x-axis. How about a -2? Okay, looks like we're getting an arm down here in the third quadrant, more or less. Let's put in -4. And -8. Yeah, so that appears to be approaching that same line. And actually, that line is just the line y equals x here, this diagonal line. And you'll see on the right-hand side, it's approaching it from above, and on the left-hand side, it's approaching it from below and getting closer and closer to the same number. So I think we've definitely got a slant asymptote. What happens to this in the fractional area? So let's put in a -1/2 here. So that's interesting. So on the right-hand side of the graph, we get this sort of like V shape. But on the left-hand side in the negatives, it's definitely more like an open shape. It's not quite such a hairpin turn. Let's try -1/3. Hmm. Well, that is definitely an interesting shape. You can see we've got 2 arms. On the right, it's all contained within the first quadrant, but on the left, we've got second and third quadrants. So what could possibly be going on here? Well, I think I'm going to start with the fact that there's a slant asymptote at y equals x. When you have a slant asymptote, and this definitely looks like that, you're going to have a power in the top that's higher than the power on the bottom. And you could put, think about x squared over x, but that would just simplify to x. So this would be the line without all this other stuff going on. So probably something has been added or subtracted or something like that. Um, it might not be x squared though. So like the next way you could do this is have x cubed over x. I think you'd get something similar. But again, this would just simplify to a quadratic. So maybe something's been added. So let's look at the points 0 and 1. We want to get infinity at 0. So maybe this is x cubed over x squared, and that would simplify to x. Yeah, but maybe something's been added or multiplied. So at 0, this would still give us that 0 on the bottom of the fraction to give us that infinity error. At 1, we'd have 1 cubed over 1 squared or 1 squared over 1, uh, we need to get to 2. And we saw something like this last week. So either multiplying by 2 or adding 1 would do that. At 2, let's just think about this. At 2, we're getting 2.25. So if we just had x squared over x, that'd be 4 over 2. We'd need to add a quarter there, and certainly not multiply by 2. What about x cubed over x squared at 2? That would be 2 cubed over 2 squared. That'd be 8 over 4. And we're getting 2.25. Oh, I see. So what if we... So I'm seeing this 0.25, and how are we getting that? I'm noticing fourths on the bottom of this fraction. What if we had 1 here, and then we'd get 8 plus 1? That'd be 9 over uh, x squared, 2 squared. So that'd be 9/4. That would be 2 and 1/4. Does that work for just 1? If I put in a 1 here, yeah, we get 2 on top. 1 cubed is 1 plus 1 is 2 over 1 squared is 2. That works. Let's try this with some negative value. Oh yeah, -1 would work. So -1 cubed is -1 plus 1 would be 0. So you get 0 on top and 1 on the bottom. Let's put in a -2 and sort this out to make sure we've really got it here. So a -2 quantity cubed plus 1 over -2 quantity squared. So -2 cubed is a -8, and then plus 1. And -2 squared is a +4. So this is going to be -8 plus 1 is -7. So -7/4. And we've got -1.75. Yeah, -7/4 is -1 3/4. And that's what we got here. I think this must be it. This one wasn't working. I think this has got to be it. We've tested it with 3 or 4 numbers. I think we're going to call it and just see. Yeah, so x cubed plus 1 over x squared. And let's graph that. That is a strange looking graph. You can definitely see that slant asymptote here and then the vertical asymptote at the y-axis. Well, how did that go for you? These rational functions get pretty crazy looking pretty fast. Let me know. Thanks, everybody.